Welcome everybody again. Tommy, if you would, please start us off and just give us a sense of what your role at HP as a Chief Technology Officer.
Yeah, it's a very broad role.
Your mic just dropped. It's in your lap.
Here it is. CTO, but I am clumsy. The role is very broad, and basically, the focus is customer faced. A lot of CTO roles are internally faced; they're dealing with the research directly. We've designed this role to be more outward looking, working with customers. For instance, I spent all day Monday. It was at the White House with 150 experts on AI, and our discussions was with the Office of Science and Technology Policy, looking at what future policies should we have in regards to AI, and where do we think this trend is going, and how can we booster the U.S. workforce to be knowledgeable and able to fill jobs in evolving markets. Tuesday and Wednesday, I was in Boston at Quantum Tech, and there is a revolution coming on in quantum technologies, and I'm not talking about quantum computing necessarily, but quantum sensing, quantum encryption, quantum random number generator. There is a worldwide investment in China's investing equivalent of $50 billion a year in the quantum communication world. There'll be a quantum internet before long. Quantum memory could make the cloud go away. And so I get to play with all these fun things that are kind of forward-thinking, trying to make sure that HP is positioned and looking to be a thought leader in these new fields that are coming out.
That's exciting. If I want to take you back a little bit, as I was listening to the group and hearing all the Seahawk passwords, it occurred to me just as a starting point, it feels like there are now more entry points for cyber threats than ever before.
Absolutely.
So when I'm thinking about how can agencies, and a lot of the audience are state and local groups, how can these agencies best protect themselves and the many endpoints, including, I'm guessing it's desktops, it's PCs, it's laptops, it's printers, it's mobile devices?
Any connected device, it's the Internet of Things. First, I'd like to comment on the Seahawks. I'm with the Colonel. I played football at Navy for Steve Belichick, and Bill was my age, so I grew up with Bill Belichick. And we like Russell Williams. He threw a great pass in that Super Bowl. That really, I'm sorry.
You get a little in trouble here.
Yeah, in the wrong town.
I had to lose the audience.
But the device endpoints are critical. Even cloud. Cloud's not secure if you don't have secure endpoints. It's the entryway. And I don't know how many of you go to hackathons. It's a week time pastime for me. It's a fun event. It's a sporting event in every sense of the word. Sometimes more interesting than a football game if you understand what's going on, because the strategy is amazing. But the youth that are there are just so inventive and so innovative. And you'll find some really great talent there. But the thing they go for to get into the network, first attempt, is they go for the printer. Why? Because most printers aren't protected in the least. Most of them still have admin passwords on there because nobody bothered to set up a password on the printer. They just plug it in and push go. And so there's a lot to be learned about protection on endpoints. We invest about $3 billion a year in research, and for a $60 billion round number company, that's not unusual, particularly in the Silicon Valley area. There are companies in this neighborhood that invest significantly more. But of that, about half of that is making our products more cyber secure. And so we invest significantly in printer resources, and we claim that we are the world's most secure printers. And the reason I'm confident saying that is the lawyers let me say that. So I'm pretty sure it's true, but I'm convinced it is. But you design it in as a factor in your design from the very beginning. The way to get secure products is that has to be the primary design consideration over size, weight, power, or anything else, even aesthetics. I've got my leather laptop with me just because it looks like a notebook, but it's a i9 powered, 32 gigabyte memory, monster machine with a 5G SIM card in the back, so I don't have to go on Wi-Fi. But it's things like this. Every year we get better. And it's better than building a system and bolting on some security on top because it works better. It's an integrated system. And when we're doing it that way, we're producing some pretty good cyber products. We're in the 6th generation of our cyber improvements out in the market today. The 7th generation is in test in our labs right now. And we're designing and planning for the 8th generation a year from now. And that kind of continuous improvement is the only way you're going to be able to combat the advanced persistent threat, because they have resources and they're investing in methods that could combat the things that we're doing.
So then let's also talk a little bit about this. Scaling up from the agency network, how can agencies ensure the security of their supply chain and any other supply chain with which they interact?
Great. In fact, to be here today, I'm missing the vote of the DHS Supply Chain Risk Management Task Force. And fortunately, all the work's done. I've already sent my vote in, so I didn't have to be there. But it's 60 people that are on the task force, 20 from the IT sector, 20 from the communication sector, and 20 government from all agencies in government are on this task force looking at supply chain risk. I co-chaired the threat evaluation working group on this task force. And you think we had about 120 SMEs that supported the threat evaluation. People don't think of threats the same way. They think of it very broadly. And you get some macro level threats and you get some micro. And I can't go into any details until the vote's done, and about 2 weeks from now you'll see a report being released from the White House and be sent over to the Hill, a summary of that report. But there was an individual from the NRC, for example. A threat to him was a specific component on a specific circuit board that went into the reactor control systems that determined whether the rods were up or down. And any way you can mitigate or prevent any changes to that component, that was the threat that he was focused on. And other people would see threats, and particularly DHS or the critical infrastructure protection people, at the very macro stage. So people think of threats very differently. And I think when you're looking at it from your agency, I would refer you back to the NIST risk management framework. It's what's important to you, and where is it you get the biggest bang for the buck for your expenditure of time, effort, or money. And that's where you try to look at where can I best apply our efforts. And it may be training. You heard some great advantages of what you can do with training to prevent people from clicking on the bad links. Now, if you had an HP computer with our Sure Click capability, which is just a marketing term, but what it is when you click on a link that's going to download some malware, it clicks into a virtual machine. So the malware works in a virtual machine, and any damage is done to the virtual machine. And when you close the browser, it disappears, and the malware goes with it. And so there's some advantages in designs like that. You can invest in products, or you can invest in training, or you may invest in a whole different way. Ransomware, I'd be scared to death if I was a city or a state, or even the feds, can be, because they're targeted, and they're looking at the weak sister first, is trying to hit the point where there's least resistance.
So I'm going to ask you a little bit about Baltimore in a second and
Okay.
some ransomware, but it occurred to me to ask, tell me what HP is doing itself to improve the resiliency in your own products.
Well, that's a great question. The resiliency in our products really goes back to that initial design. If you go to the NIST 800 series, we had our senior leadership meeting with Dr. Copen, who's the director at NIST, 2 weeks ago. And we were talking about 800-193, which is hardware resiliency. And there's a list of about 12 things that are required in the 193 document, and then there's 4 others that are optional. And we hit all 16, plus we do a couple of things that aren't even in the document just because we think it's the right way to design systems. And it's looking at hardware resiliency. Most of this applies to under the operating system. And the reason that's important is because RATs, or remote access terminals or technology, they exist underneath the operating system. So Microsoft, God bless them, they get better every year, but you can avoid Microsoft protections altogether if you go into the BIOS. And that's where 193 comes out. You will see released here in the next, well, hopefully few weeks, maybe a month, NIST 800 and 194 for comment. That needs to be out today, but they're trying to get all the comments from industry resolved and mitigated before they release the draft document. 194 is going to be on software resiliency. And as you heard in the previous group panel, resiliency is really the key. It's one thing to stop somebody from getting in, but eventually they're going to get in, and how do you keep them from doing any damage, and how do you get back up and run? I use the analogy because of my age. It's the Timex commercial. It can, the Timex diver dives off a bridge in Acapulco and hits the water, and he shows that the watch still runs. It can take a hit and keep on ticking. And that's what you want your computer systems to do. They can take the attack, but they can continue to operate. And we've done some designs, particularly in the BIOS level, that if somebody gets into the BIOS, they've got about a minute to operate before it's detected, kicked out, and reinserted from a cryptographically secure ship.
Tell me what sort of role do data protection and deep learning play in ensuring an agency's overall security? And think about that in terms of, how will this impact in terms of future threats?
Excellent question. AI and cyber are coming really close together. And the more you look at data science, and my doctorate was in economics, but studied econometrics, so I became a data scientist by default, not by design. The data science field feeds into AI. AI is nothing without data, but AI is the way the threat is using to mitigate change malware just a little bit, so your signature detections, they don't work anymore because they're being changed, minor changes, so the signature changes, and thousands of times a day. And so how do you prevent future malware? So we've looked at that, and so signatures aren't working. It protects something, but not much. It's not going to protect you. Machine learning became the trend. And if you understand machine learning, this is a pretty tech-savvy crowd. And I think any crowd in Seattle's got to be tech-savvy. This is just a great city. But the machine learning is, image recognition. Is it a dog or is it a cat? Several forms of machine learning. One of the forms is neural network, and we're using a convolutional neural net. It's a nonlinear system that has taken 100 million examples of malware and run those through a very large processing system computer and come up with just essentially the DNA, the makeup, and created an agent that is, terabytes in size because of the hundreds of millions of examples, almost 1 billion examples of malware, but reduce the agent down to about 100 megabyte size. So it can fit on an endpoint. It can fit on a printer, it can fit on a computer, it can fit on a server. And when it's there, it's in our lab, it's testing to detect about 99% of new malware that's never been seen before. So that's how we're approaching it. Now that's a lab approach. We've had it out since April. We're getting good results in the field. And as you know, anything you do in the lab, don't expect the same results in the field. You got to get it out there and you got to get it tested and see how it works out in the field. But so far, the feedback's been very positive. And but we can't stop there. We can't pat ourselves on the back and say we're done because, the threat is going to figure out a way around it and figure out how it works, what the agent does, and that's okay because we're going to be improving it every year. Part of our investment is to make sure this system and this algorithm keeps updating as the threat evolves.
So I'm going to do a quick wrap-up question, which is, what can people learn from the hit on Baltimore? And as you're looking at that, tell me what that says about the future of cybersecurity.
Right. And I think we addressed it pretty well in the last conferences. Don't pay ransomware. And Baltimore suffered, and they eventually paid. And I forget what it was, 18 million or something. And it would scare me to death to fork out that kind of money and then find out 2 months later they're hit again. You know, what prevents them? What did they change such that they wouldn't be hit again? And it was a pretty simplistic attack. City of Atlanta was hit just before then. And I spent a month ago, I was in Atlanta, Georgia, and speaking with the state of Georgia CIO. And, you know, it's a big concern for the state. You know, how do we stop this again? And if you hadn't figured out how it happened and what the agent was that we used or the malware that was attempted to be used, and they did figure that out in Baltimore and Atlanta, you know, there's nothing that says it won't happen again, and so you're paying off to do that. I like the response that said, you know, you got to have 3 systems in backup, one that's offline. I think that's excellent advice, and I would certainly take that to the bank. You know, another way is you store it in 3 different clouds, and you know, and is that still protected? Maybe, maybe not. Depends on how the threat's attacking it, but at least you give some resilience, some capability if you figure it out what's going on. And what some systems are doing today is they're looking at command systems within the processor, and if you get a certain order of commands, that's indicative of malware or ransomware. And so it's, you know, find all the data, copy all the data, encrypt all the data. Yeah, that can be a problem in malware. So anytime you're encrypting data, maybe a flag should go up in a dialog box. Do you really want to do this? Now that may be defeatable or not, but it's certainly an area that you need to be looking into. And that's the type of thing we're trying to look at our products, is how vulnerable they are. I think we do have the world's most secure printers, but I'm also convinced we're probably 2 or 3 years ahead of any of our competitors in the world's most secure PCs, workstations, and servers. And it's because of investment. You don't get there unless you're investing the time and money and effort. And we've got some brilliant people that are investing the time, and we're spending a lot of money.
There's so much more I want to ask you, so please stay afterwards, and I'll continue to ask, and everyone can come up and ask you as well. Thank you, Tommy.
Thank you.